Hello everyone, let's continue with the referential integrity. So just consider if a referential integrity means foreign key reference. So that means one table has some key, some value, some attributes, which will be the primary key of another relationship. So we have data referential integrity constraints. If this constraint is violated, so what's the things we can do? So of course we can say we don't want to that constraint to be violated, so we can reject the related actions that will cause this violation. But this one maybe is not always the best way, because we may continue the action, but still put the database in a consistent condition. So here we talk about the cascading actions for the referential integrity. So that will be, for example, when we want to delete a tuple from the department. For example, one department, that information will be gone. So the related department will be not there in every related tables, like a course. So there's no course offered by that department. So that means we want to delete a tuple from the referenced table, correct? Or we want to update, we change the name of the department. So that means if we do like this way, how can we do the changes on the referencing means the course, because here is the course references the department. So if we change this one, so what will be done, what should be done in this table? So we can have the cascade means when we delete, for example like this one on delete, when we delete a tuple, make some attributes with some values not available for the department name, then we also need to delete related tuples, so called on delete cascade. So this is just for this department name, so we're looking at this one. Okay, and similarly, if we change a department name, we also can update accordingly for the related tuples. So that means if this one in the past we call CS department, now we call it maybe CSCE department, computer science and computer engineering. So we also need to revise or update accordingly. Okay, so this is the idea. So basically we can still carry the action on, but without violating the constraints. So this is the concept. Of course, you may have different some other choices. So without using cascade, we can using set null or set default. So that means still keep this on delete, on update, you replace the cascade with set null or set default. So that means at least there's no violations. There's no violations null, because null is the default value for any attribute. And set default, what's the default value for that attribute? If we have set that one, we just change that one to be the default value. Okay, this is about that means how to handle the referential integrity violations. Okay, we use basically we often use the cascade. So when we create a table, we define a table, we also handle this foreign key reference constraints based on these rules. So let's look at, for example, if we do not just that means we don't just only in one statement. For example, in the previous one, we delete, we update. That's only one SQL statement. We are doing something in a transaction. So how to handle this one? How to handle these transactions? I mean, during these transactions, there's some constraints. Integrity constraint was violated. So how can we handle? So a transaction will contain several statements. Just consider. So as a whole, this is transaction, right? We mentioned in the chapter 17. So in the end, we'll do commit. Okay. So it is possible we may violate some integrity constraints in the middle, in between. That means not in the end. So once we finished, that means we temporarily violate some integrity constraints. But once the transaction is finished, then there's no constraint violation, integrity constraint violation. So how can we handle this? So that means we have three choices. Okay, we have three choices. So like this one, if we have create a table called person, and then this is ID, person name, and mother and father, and the primary key is ID, and then we have the father and mother also need to refer to itself. That means so father and mother also a person, so also have father and mother, right? So this is referencing one, and this is referenced one. Okay, so these attributes referencing the person table. So how to handle this one? We have three choices. So that means during the transactions we may do update, delete, and so on. So if we want to insert a tuple, but we don't want to violate the constraints, integrity constraints, so we want to insert a tuple to the person. So the person must have father and mother. So we can first do insert father and mother first before we insert that person. Because if you don't do that, so we don't have the father and mother tuples in the person already. So that means this one violates the foreign key reference. Okay. Or you can just temporarily set this one to be null values, because that will be the default value for any attributes. So set null, and later we will update all the inserted tuples with a null value. Okay, with a null value. But if you declare this one, for example, you add this one to be not null, then you cannot choose this option, because they must be assigned a value which is not null. So but here we don't have that one, right? We don't have mother, father, not null, and then comma, not null, and then comma. We don't have that one, so we can do this way. And the last one, maybe more general one, this one is called a defer constraint checking. So the basic idea is that we allow the violation temporarily, but we check the possible violation before we finish the transaction. So that means that you can declare this constraint is deferrable. That means you put a deferrable after this one. Means this constraint will be checked in the end of the transaction, rather than just right away. Okay, this is about the integrity constraint violation during the transactions. That means a list of statements as a whole to finish one task. Okay, and the next one we can also consider. For example, we already talked about the check. In fact, the check conditions can be a complicated one. So in fact, check, we said that the P is a condition. In fact, in this predicate, we can also have a subquery. For example, like this one. For this one is about the section table, and then each section has a time slot ID. That means what is the time for that section. And then we said this ID must be in this set, because this one will perform a query to get a set. What is a set? Because the time slot will repeat many times, so we don't want to just every time we write out the time, so we can just assign a time slot ID, because even every day they will repeat, okay? So this is the reason we will just create a table for time slot. So this is time slot table, and then of course the primary key will be time slot ID, and then will be the time. So we select, that means query the table time slot, get all the time slot IDs. So the section time slot ID must come from this set. This is the idea. State that the time slot ID in each tuple in the section relation is actually the identifier of a time slot in the time slot relation. So that means it must exist, okay? We cannot create a new time slot ID in the section table. They must come from the time slot table, okay? And the next question is that when will be this condition checked? What situations? So of course, if we change the section table, we'll check this one. How about other situations? So that means this is like the referencing. This is referenced. So either one has changes, we need to check this one. For example, this one changes, you change one tuple, its time slot ID change to a new name, new value. You need to confirm whether it is allowable. And also similarly, maybe we assign more time slots. We change the time slots, or we use different values for this one. So we change this table is also fine. That means we also need to check this constraint as well for all the tuples in the section table as well. Okay, so that means not only when we insert or modify a tuple in the section, but also when the time slot changes, the relationship, the table time slot changes. Okay. So the last one about this section is about assertion. So in fact, assertion is that we want to perform a database condition check, database level. So that means it's a predicate expressing a condition that we wish the database always to satisfy. Let's look at the examples. For example, so this means if it's database level, means it may be related to multiple tables, not have to be one table. So it's very possible multiple table. If it's one table, we can use constraints. But if it's multiple tables, in fact, we need to create an assertion. So this is about the consistency of the database. Like this one. For example, for the student relationship, for each tuple of it, the total credit must equal to the sum of the credits of all the courses that have been taken by the student. So that means even it's not the multiple tables, but still need to do summation. You need to sum all the credits. Okay, yeah, this one is still involves multiple table, because this one says the text. The text the student takes some courses and get a lot of credits. So you need to sum all the credits of one student in the text table. and then to compare with the total credit in the student relationship. Okay. And also we have second example. For example, one instructor cannot teach in two different locations. So this one also is like checking the unique. For example, at the same time, whether you can find the instructor was assigned to be two rooms, okay, two sections. Okay, for here I added one term word called physically. So that means, of course, we may use IVN like this remote teaching, but we can only say there's one assigned room at one for one class. Okay, and next, then how to create an assertion? We are just like create a table, create a view. So you create an assertion, use this keyword, and then you give a name to it, and then check. And then in this one, you will just write the predicates. So that means this one will be, can have a subquery, can be a complicated one. Okay? So this one is like what you want to do. Want to meet the conditions, the condition you want to perform on the database level. So you write these things. Usually it involves a query. Okay, so write these predicate inside of the parentheses, and then we assign this one to be assertion. Okay, to be assertion. Okay, this is all for the integrity constraints. Okay, integrity constraints. So let's continue with the fifth section, SQL data types and schemas. In fact, we are only focused on the data types, not the schemas. So here we talk about database data types. That means we have learned some data types in the chapter 3, but here we talk about some other additional built-in data types in SQL. So the first set of new built-in data types are date, time, timestamp, and interval. So all of them about a date, about a time. Right? So the first one is the calendar dates. That means we list months, year, month, and date in this format. So the year will be 4 digits, and the month 1 or 2, and then the date will be 1 or 2. So in this example. So next one will be the time in terms of hours, minutes, and seconds. Okay, in this format. So next one will be the timestamp. Timestamp, that means we just combine date and time together, separated by a space. Okay, that will be timestamp. And then interval means the time in between. So we can do, for example, in between 2 dates, 2 time, or 2 timestamps. So this one means we can just do subtraction, okay? Subtraction between. Okay, of course you need to perform with the same type. So this is about a period of time. For example, like interval is 1 day or 1 hour or some days and some hours and minutes and so on. So you can subtracting a date, time, and timestamp value will result in an interval. Of course, you can also do addition. So add one on top of another one, so you get an interval as well. Okay, similarly based on the same type. Okay, this is the first batch of new built-in data types. So next one we talk about the large object types, the second batch of new built-in data types. So considering we want to save some text, some documents, some images, some videos, and like those things, usually they will be much larger and the size is also dependent. So to save those objects, we have new data types for them. The first one is the binary large object blob. Binary, for example, like an image, it contains, it will translate it to 0 and 1 values. So for this things, we just need to use a large object to save an image. And the next one, for the character large object, for example, we want to save some text document. So for this one, each unit in fact is a character. Okay. So that means that we can also claim, for example, how much size. Because this is only for knowledge purpose, we didn't give example, but you can also, for example, after the blob or club, you add a parenthesis, and then inside the parenthesis you add the size, and then you define what attribute is this type. Okay. For example, image is blob, and then parenthesis is 10 megabytes, just like this way. So in fact, because these are very large, so when we perform a query, we return a result which may be a image, maybe a document. Anyway, it's a blob or club large object. So instead of returning the object itself, we just provide the location of the file of the object. Means we just provide a pointer to that object. That will be enough. Okay, for more details, if I'm interested, you can look at the book. So here we just inform you we do have some other data types to cover this purpose. The third one is user-defined types. That means we even can create data types by our own. So that means some specific data types. For example, like this one, we have the grammar to create a data types like this way. Create type, and then the type name, and then as, and then what is the type, what's the definition of the type, and then final. So this one, of course, depends on the SQL standard. This is required by the SQL 1992. So you can just consider this is like the Java code. Final means we cannot access this type, we cannot change it. So of course it is not very meaningful, but you can just understand like that way. But in fact, in some other DBMS, they may just do not need it, have this word. Just ignore this one. So once we create this dollars type, so it's a numeric 12 and then 2, means in total it have 12 digits, and then after decimal have 2 digits. So in total before we have 10, after decimal we have 2. So like a cents, character cents. So once we define the dollars, we can use it in other locations. For example, we create a table, department, and then the department name, voucher, building, voucher, and then budget. We use the dollars, then the how much, and then we use this 12 to 2. So that maybe is already enough to cover this one. But before the decimal have 10 digits. Correct. Okay, this is the idea how to create a data type. Just give you one example for your reference. So we can also create domains. So here is the grammar. So create domain, and then the domain name, and then the definition of the domain. For example, like this person name, and then is 20 characters, and also the name cannot be null. So you can find here we have 2 parts. The first one is about the types. The second one is about the constraints or integrity constraints. This is also the difference between domains and the types. They are similar because both define the range of the allowed values. So that means here the character 20. But domains allow us to add integrity constraints. For example, like this not null. So that is the main difference. Of course, we have another difference we didn't list here. In fact, domains are not strong types. As long as the domain are consistent, they are compatible, we can assign between, that means cross domains. So you, for example, person name is check character 20, maybe another one also have this similar one, so we can allow, but the types are different. We cannot allow that competitive. And here we give one example. That means in addition to the range of the data type, we also add constraints. So we create a domain, degree level, and a varchar. So this is a domain name, degree level, and then the type, the range is varchar 10. So that means we have allowed 10 characters for this degree level. That means it's varchar that's used as needed. And then we have constraint. That means this is keyword. So for this domain, we add a constraint. So this is constraint degree level test. So this one is not a must. We added this one is just want to, for example, if we have violation about this one, and then we can notify the system this is what type of violation. So degree level, even you ignore this constraint degree level test, it is still correct, because we use check, we added this condition, these constraints after we finish the range. So that means we have the range and then the constraint. So we have the check, and then inside it the predicate. Predicate is the value in this one. That means the value of this all of this domain degree level must be in this set. Can be only in bachelor's, master's, and doctorate. So this is the idea. Of course, you can use sometime maybe use larger or equal to, and or something. But this one is just like one example is a predicate inside of this one check P. So we have learned before. And then you can use the constraint name to refer to this violation. If you ignore that one, is still correct. Okay, this is also the last slide about this types. Okay, types. So let's look at the index definition in SQL. So just consider we initiate a query. So we need to load all the, without an index, we need to load all the records. For example, we want to search computer science students. So we need to load all the tuples in the student table, and then examine which one in the which ones are in the computer science. So even we only maybe have to look at only maybe 10% or 1% of the total, but we still need to load all the tuples of the tables in the memory. So it's not an efficient way, because we only use a small portion of the records. So in fact, how about this for different departments, students belonging to different departments, we create an index for each of them. So that means, of course, we said we create an index with respect to the department name, and then we department name, DPT, and the name. So that means we have computer science, we have history, we have geology, and so on. So each one we just map to some locations of the record. Okay. So with this index, we can easily find out which records are needed. So we don't load all of them into the memory, and then we only load the indexed ones. For example, only belonging to computer science, and then into the memory, and then we do the complete rest of the query. So this is the idea. That means we apply the indexing on attribute maybe it is possible to be a attribute list as well. So here is just one example. Index, of course, index we have performed on a list of attributes. So we list the attributes in this set. So on a attribute of a relation is a data structure that allows the database system to find those tuples in the relation that have a specified value. So that means specified value. How to specify? We group all the records in the student table with respect to the department names. So if we create, for example, create an index which is about this attribute, about the student and then department name attribute, then we will group them accordingly. So if you only have interest in the computer science department, we will just return those records. So for that attribute efficiently without scanning through all the tuples of the relationship. So this is the idea. This is the grammar to create an index. So these are the keywords, like the create table view, create index, and what's the index name on what relationship, and then list all the attributes. If we have multiple attributes, then we are just sort accordingly. Just first one we based on the first, and then second one based on the second. We do different. We have a final classification, final partitions. Okay. So look at this example. We have defined a student table, so same as previous. Okay, and then we create an index, which is create index student depth index. So about the department. Depth means the department. So the index name is this one on the student table, and then which attribute? Department name. So that means we create index for each department. Okay, each department. And then when we initiate this query, select star and from student where department name equal to computer science, we only load those records belonging to computer science. We will not load all of others, and then continue the rest. Okay, you want to do whatever. So here just want to print out all the records in the computer science. So this one will be more efficient rather than just load all the records of the student table into the memory and then examine one by one. Of course, creating an index will take some physical space as well. So in fact, this will just relate depending on the decisions of the DBA. So mainly index is not one part of about a SQL. In fact, it's about the physical design. It's not the logic design. So it's not the standard. It's not among the standard of SQL. So it's like additional features, but we use the SQL commands, SQL statement to do that. So that's why we mentioned here. It's not the standard one, but it is useful. And also, how to create the indexes, it will be not so difficult, so easy thing. So we need to be careful as well, because it's like a balance. Okay, this is just a simple introduction about the index. Okay, we'll continue with the last part about the authorization. Okay. So authorization means we want to grant some privilege for some users to access or to update some data. So when we initiate a query by a user, we first check whether the user has the appropriate privilege to perform that action. So here we look at what are the privileges which can be granted. So the first one is the read. That means we can allow users to read data but not change data. And insert, you can insert new data but not change the existing data. Update, we can change the existing data but not deleting the data or inserting data. Delete data means we can grant people to delete some tuples. So each of these one we call these different types of authorization we call a privilege. That means the read and the insert, update, delete. Later we have examples. So that means of course you can grant one or more of such privilege to one or list of users. So later we want to just learn how to grant privileges to different people, different users. So besides the privilege related to the data, we also have privilege related to the schema. That means the database level, for example, tables and so on. So for example, the first one, we can allow people to create an index or delete index. The second one is that we call it resources, it means we can add new tables. The third one is that we don't add a new table, but we change the table definition. So it's called iteration. The last one is the drop. That means we can delete a table. Okay, these are the privileges related to the database level. We call the schema, database schema. So let's look at how to grant privileges to people, to users. So the grammar is grant privilege list. Privilege list can be select, insert, update, delete. So that means we just list the privileges here. And then on, that's keyword, on a table or a view. So we give the table name or view here, view name here. And then to user list, to some people or some group of people. So the user list can be one single or list of user ID, one ID or a list of user ID, so the user IDs, or just to public, means all the current or future users, or a row, so which will be mentioned later. And then let's look at the example for the here. So it's grant select on department to Amit and Santosh. So select is a privilege. If we want to grant more privilege, we can just add comma and so on, delete or insert or update on which table, department table, to which users, so the user ID, Amit and Santosh. Okay, so for here is about a table, but if we grant privilege on a view, this is only just say we have the privilege to perform such operations on that view, but nothing related to the underlying relations. So that means we can change the view, but does not mean we can change the relations. Okay. And also, if we grant a privilege to a person, we must already have that privilege. Okay. And in fact, the highest, the top the top person which have all the privilege will be the DBA. So let's look at the examples for different privileges. The first one is select. This means we can read a table or just query a view. Here give one example. Just grant users U1 tier U3 select privilege on the instructor table. So it's a grant privilege list, which is only one select on a table instructor to users user list U1, U2, U3. Okay, so let's look at second one, the update. So that means people can change or modify a table or a view. So for here, in fact, we can also just only allow people to update some attributes. If we only allow people to update some attributes, we need to list those attributes right after the update. So this is one example, grant, update, and then parentheses, list all the attributes in the parentheses. So update budget, okay, parentheses budget on the department table to users Amit and Santoshi. So that means we can only allow people to change the budget attribute in this department table, cannot change others. Okay. for these two users. Similarly, for insert, we can also do as a update. We can insert. That means we can only assign values for some attributes. So you can just list those attributes right after insert. And then for others, we can just put as null values or just default values. Okay. And then delete. That means delete a tuple, so we don't have any things like the previous update insert. So delete the whole tuple. And then if you don't want to list all the select, update, insert, delete, you can just use a shorthand called all privileges. That means this will grant all of them to users. Okay. We can grant privilege to users. We can also revoke the privilege from users. So in fact, the statement revoke statement is very similar to the grant statement. So it's a revoke privilege list. In the previous, it's grant privilege list. So here we want to get it back. So on a table or a view, and then we use from, right? User list. So that means from the users, we want to claim back the privileges. Example for here, for the query, the read. So for this similar like the previous one, we get it back. We prefer the grant select. Here is a revoke select. So on student table, from those users, user list U1 till U3. So for here, the privilege list, if it contains maybe all, it can be all, just all. That means all the privileges will be claimed back. Okay, that revoking may hold. Revoking the person whose privilege will be revoked. If a revoking list means the user list includes the public, so that means we want to revoke some privilege for some table or views from public. That means all the people. Okay? That means all users will lose the privilege except those granted explicitly. So that means if we already grant some privilege to some specific people, so those people still have the privilege, but for public ones, for others, their privilege will be dropped. And if one privilege have been granted twice for one person, one user, then one revoke may still cannot just affect other grant. So that means we may still have the privilege after that revocation. And the last one is that if, for example, we grant a privilege or other privilege which, depending on this privilege, will also be revoked. For example, if we revoked all privilege, so all the privilege depending on this shorthand, all privilege like the select, insert, update, delete, of course they will be also revoked. Okay. Let's look at the roles. In the previous, we talked about the user list. User list can be a user ID or list of user IDs. Can be a public, can be also roles. So that means this is something like how to partition users. For example, can be user IDs, separate users. Can be public, all the people. But here we want to group users into different groups. So assign a role. That means a group name to it. For example, we are students, we are teachers, we are instructors, we are maybe deans, we are maybe directors, like this one. So this is the same idea. That means this means all the people in the same group will have the same always, not always, only have the same privileges. So if like that, we can just grant privilege to the same role, which cover all the people, all the users. So no need to grant privilege to each person. So this is the reason. Okay. So to create a role, we can just give a role name. For example, create a role instructor, teachers, and deans, and so on. Okay. So this is the create role and then a name. For example, create role instructor. Once we create a role, we can assign users. That means just classify people into users into different groups. So grant role to users. So that means assign a role to a user or users. Okay. So here, let's look at the examples. So for example, here we create a role instructor. Okay. So that means we want to create a group of people called instructor, and then we want to classify Amit to this group. So grant instructor to Amit. So this is a grant role to a user. Okay. So that means we want to assign. This is the role for this user. Grant a instructor to a user. Okay. And after we have this one, we can just grant privileges to the roles. So that means these people belongs to this group, and then we want to assign privilege to this group. So for example, we want to access grant the read data access table access query, grant select on. So this is same as previous grant on. Grant on select privilege on tables takes to this row. So this is a row. Okay, grant this one. In fact, besides to the row, we can also, that means roles can be granted to users, but also can be granted to other roles. So let's look at this example. This means what? Just we can assign people to a role, but also we can assign role to another role. Okay. For example, we create another role called a teaching assistant, and then so this is the instructor is a large group, and then in fact the teaching assistant is we can also grant this one. So that means grant teaching assistant to instructor. So this means we grant this role to be another to be that means this one to be another example. That means this is instructor belonging to this role. Okay? This is one role, this is another role. So instructor role becomes a subgroup of teaching assistant. So this instructor we have all the privileges because this is the parent, this is the child. Okay? So grant this one Amit to instructor. So this is like an example. This is only one example. This one, of course, this one we inherit all the privileges of this group. Okay. And then we can also create a chain of role. Chain of role. That means let's look at this example. Create a role dean, and then we grant instructor to dean. So dean is also instructor. Okay? Dean is also instructors. Okay. So this is like we have instructor, and then we have dean. No, we have instructor, and then we have dean. Okay. And then we have the example Satoshi. Okay, Satoshi. So this is the highest, the root, and then this one has the example which is dean, because all the instructors are dean. So and then Satoshi is a dean and is also an instructor. So that means this is like a chain of rows. This is row, this is also row. Okay. Okay, that's all for the rows, and then we'll continue with the next one, authorization of views. So we mentioned before we can grant privilege to both tables and views. So let's look at how to grant privilege to views. So we do have such usage scenarios. just consider in one department, let's assume it is the geology department. So the geology department staff we have access all the staff, maybe we just assume all the staff in the geology department we have access on the salaries of all the geology instructors, department instructors. So that means we may already create a view for this one. So that will be select star from instructor where department name equal to geology. So we assign the view name called geo instructor. And then next one, we want to grant all the staff in the geology department. So we call it geo staff. Maybe we create a row and then list all the people, all the users for that row. So we can grant select on geo instructor to geo staff. Means geo staff is one member, one instance of the geo instructor. Okay, so that means not that one is the grant the privilege. Here is the not a grant role. Grant privilege select. That means for the geo staff we have the select privilege on this view. Okay, so that means any geo staff based on the user ID, and then if we initiate this statement select star from geo instructor, then it will have access to the view, okay, because it already granted the privilege. But let's look at what will happen if we have the following two questions. In fact, when we create a view, it is only just like a macro, we mentioned it before. So when we implement or perform the operations, we need to replace that view definition, that view name by its definition. So select star from geo instructor will be replaced by the select star from instructor where department name equal to geology. So but here we access the instructor table, correct? But if the geo staff does not have permissions on the instructor, because in the instructor table it contains of all the instructors belonging to different departments, so the geo staff only have access to the salaries of the geo instructors, not for other departments. So what will happen for this one? So in fact, to solve this issue, we are just before replacing the view name with its definition query, we check the permission first, and then if it has the permission, we can allow the following operation. We don't check till we replace the view by the definition. Okay. So let's look at the second one, is creator of view. If creator view do not have some permissions, so assume for example if it's select permissions, then what will happen? So we grant something to others, we need to have that permission, correct? So that means we must have that permission first, otherwise the grant statement will be denied. For example, we grant select, so the creator of this grant must have the select. If grant delete or insert, the creator must have that privilege. If the creator has not that privilege, didn't have that privilege, then this will be denied. Okay, this is about view privilege authorization. So the last slide is about some other stuff we put together here. So other authorization features. Let's look at the first one for the references. So in fact, this is about a foreign key reference privilege. Usually we don't allow people to create a table. So only the creator of the table can do changes. but we do allow users to add foreign key references constraint, integrity constraint. If like that, we need to add one statement called grant reference statement. For example, like this one, grant reference department name. So for here, it means we can only create a foreign key reference for that attribute. So we list the attributes which we can allow people to add, user to add foreign key references. Okay, on department table. So for this one to Marilo. So that means we can allow the Marilo to create a foreign key reference to refer to the department table. That means the department table will be the referenced table. You can create a table, a new table which will add this reference. Okay, add this reference. This is the reason why we want to have this one explicitly. And in default, we don't allow people to do that, just because foreign key reference will cause problem to the delete, update. So we must explicitly decide which users has such privileges. And also we have some other special cases about privilege transfer. For example, if we want to, for example, we grant a privilege to user A, user A can also grant that privilege to other users. Then we must explicitly write that out. In default, we are not allow. So this grant select on department to emit with grant option. We must add this with grant option. Then we can allow emit to grant this privilege to other users. Otherwise, emit does not have that privilege to do that. And then we have grant. Then we have other side is revoked. So revoke in default is like a cascade. For example, if emit has been revoked for this privilege, then all the related, for example, emit Satoshi also granted the privilege to others. So all other privilege will be revoked as well. Similar, that means that privilege. So that's the default one. If you didn't write the cascade, that will be the default method. But in fact, we also allow people to avoid this one. So we only want to revoke emit and Satoshi's select privilege on the department table. But if they already assigned the privilege to other users, user IDs, we still want to keep that one. Then we can put a restrict. So that means we stop. Yeah, only stop from there. Just only revoke these two users' privilege. And then we have other stuff, but mainly we already cover most important contents, maybe 90% of the contents. And some others you can refer to the W3C schools we mentioned before, some other reference for more details when you do the development. Okay, this is also the last slide of this chapter, and then we'll continue with the big data. So in the next week, also the last lecture. Okay, that's all for this week's class. Have a nice weekend. Bye.